Hi, in this video I'm going to try to explain what garbage collection is in C#. Let's start with some simple definition. Garbage collection in C# automatically cleans up unused memory. When you create objects, they take up space in memory, and over time some objects are no longer needed. The garbage collector finds these unused objects and frees their memory, making sure the application does not run out of space. You can think of it like a cleaning crew that automatically removes unneeded clutter from your computer's memory. And now I will try to explain the garbage collection in a bit more detail. What is heap allocation? In C#, most objects are allocated on the heap. When an object is created using the new keyword, memory is allocated on the heap, and over time, as more and more objects are created, the heap gets filled up. An object is considered alive as long as there is a way to reach it, typically through a reference. If there is no way to reach an object, it becomes a candidate for garbage collection. How does the garbage collection process work? It has three main stages: mark, compact, and sweep. When the system determines that it needs to reclaim memory, the garbage collector kicks in, and then the first stage, the mark, is when the garbage collector identifies and marks all the live objects. During the second stage, compact, the garbage collector shifts all the live objects to one side of the heap, making all the remaining space contiguous. This simply means that during this phase, the garbage collector moves the remaining live objects so that they are next to each other without any gaps in between. And by doing this, it gets rid of any scattered empty spaces in the memory. And this helps the system use memory more efficiently and allows for faster memory allocation in the future. And during the last stage, which is sweep, all the non-referenced or unmarked objects are removed, freeing up memory. You can now pause the screen and read the text to learn how .NET uses the generational approach to optimize the garbage collection process. And now let's talk about finalization. Finalization in .NET refers to a mechanism by which objects can clean up resources or execute specific code just before they are collected by the garbage collector. Some objects may hold onto unmanaged resources, such as handles, network connections, or database connections, and these resources need to be properly released to make sure that the system resources are not wasted or leaked. And the way finalization works in C# is by using the finalizer method. This is a specific method that is denoted by the tilde character and then followed by the class name. The method takes no parameters and returns no value. When an object that has a finalizer is created, it is actually added to a special list, which is called the finalization queue. Objects in this queue are kept alive until their finalizers have been executed. And again, you can pause the screen and read the text about the garbage collection and finalization. When you use finalizers, you need to use them with caution, since, first of all, they can introduce overhead. The process of running a finalizer can delay an object's memory from being reclaimed, possibly leading to increased memory usage. Also, if an object's finalizer resurrects the object, makes it reachable again, it can cause unexpected behavior and memory leaks. And lastly, it is recommended to use finalizers sparingly and only when they are necessary. I'm going to briefly mention the iDisposable pattern. I have a separate video about iDisposable, you can check it out. But I just want to say that the iDisposable is a common .NET pattern which is used for objects that manage unmanaged resources. The iDisposable interface defines a dispose method which, when implemented, provides a way to explicitly release unmanaged resources. Okay, you have to keep in mind that as a programmer, you have the ability to explicitly request the garbage collector to perform a collection using the garbage collector collect method. However, calling the garbage collector manually is generally not a good idea for several reasons. It can cause generational disruption, which was explained a little bit earlier, and also can cause performance overhead. And maybe the main reasons not to use the garbage collection explicitly is because it is not predictable. The .NET runtime has an optimized garbage collection strategy, which is based on various factors. And manually calling the garbage collection can actually disrupt this optimization. And of course, there are some very specific scenarios where invoking the garbage collector might actually make sense. This is if you have resource-intensive, short-lived applications after releasing large resources before resource-intensive operations in diagnostic scenarios and in control environments. Okay, I have this code sample where you can see how you can actually code the garbage collector. We have a demo object which represents objects that use some memory via the buffer field, and inside our mail I have a loop which actually creates 10,000 instances of the demo objects in this loop. And after creating these objects, they go out of scope and become actually eligible for garbage collection. And on this line here, we manually call the collect method to start the garbage collection. We also use the wait for pending finalizers method to make sure that we wait for all the finalizers to run before proceeding. Again, this is just a simple example to demonstrate that you can manually call the garbage collection, but as I mentioned earlier, you might never have to do that unless you're dealing with some very specific scenarios. And this was another quick tutorial from me. I hope you enjoyed it, and thank you for watching.